Let's move on to the chemical process for efflorescence. How does it happen? Calcium hydroxide particles from the cement hydration reaction dissolve in external moisture contained within the voids in the concrete matrix. Over time, the water and dissolved salts migrate back to the concrete surface where the solution reacts with carbon dioxide in the air to form calcium carbonate. The water then evaporates, leaving the calcium carbonate residue on the surface as efflorescence. Let's start by saying it again. Efflorescence is complicated. However, it is also true that production has an important function with many tools to lower the potential for efflorescence. The most important production contribution can make is to produce concrete units with high density and low absorption. And it follows that to achieve this, we need to deliver dense, well compacted units with sufficient hydrated cement to minimize voids and pathways for moisture to move through. When we talk about minimizing water migration through the units, we should be clear that in this case, we are referring to how water interacts with the unit after curing. In other words, once units are in the yard or installed in a project. For fresh concrete up in the mixer, we should maximize the water content in order to maximize cement hydration and strength development, and minimize voids or pathways for moisture to move through later. Bottom line is during production, we want to get as much water as we can into the mix, short of slumping, picking, or pulling. We're all about minimizing the efflorescence potential because it's hard to say when it will happen. Here are some extra things to look out for. Try not to shock the units with an abrupt change in temperature. This applies particularly when it's cooler outside than in the kiln or curing chamber. If possible, open and vent the kiln to allow units to be closer to ambient temperature before they are moved outside. Shrink wrap can cause a greenhouse effect, where warm, moist air is trapped in the cube. Moisture can rise and condense on the surrounding plastic. The water then drips back onto the concrete and gets drawn back into the units. So if possible, replace shrink wrap with top sheets and banding. Lastly, placing green or low strength concrete units in the yard when it's cold outside may ensure that the cement hydration process stops before hydration is complete. These are low strength and low density units, and they will stay that way until temperatures warm up again and the hydration process restarts. This means that when conditions first warm up in the spring, we have low strength, low density product with a lot of pathways for spring rains to move through. In summary, it's all hands on deck when it comes to minimizing that potential for efflorescence, and the production team can have a strong impact on limiting it. This includes maximizing water during concrete production and producing units that are properly compacted of high density and low absorption. If you can, adjust the timing of when units are placed in the yard during cold weather. And use top sheets with bands in place of shrink wrap when possible. Include a layer separator like airflow spacers for additional protection. Thanks for joining us. See you next time.